स्केल है, कम से कम 250।
A very good afternoon to everyone, guys. Welcome. Welcome, everyone. A very good afternoon to all. Welcome, guys. Good afternoon to all. A very good evening to all. So in the today's session, we are going to discuss a numerical on working stress method. And based upon that numerical, all the numericals that are possible to be asked in the GATE 2021 are going to be covered. Clear? Good evening everyone. Good evening Abhinash. Good evening Kumar. Good evening Indra Dev. Rahina. Good evening everyone. I am good, dear Indra Dev. How are you all? अविनाश, वो जो सेशन की आप बात कर रहे हो वो हम गेट के बाद ही प्लान करेंगे. ओके, वी आर नॉट गोइंग बिकॉज राइट नाउ स्टूडेंट्स दे आर टारगेट इज गेट 2021. ओके, so we are going to plan that session after gate only. Good evening Nikhil. Good evening everyone. So in the today's session, let us start with the today's session, guys. So settle down everyone. We are going to start with the today's session. So in this session, I am going to discuss one good numerical, and based upon that numerical, your at least 5 to 6, 7 type of numericals are going to be covered for the GATE 2021. If there is any question that is asked from the working stress method, it is going to be covered through this numerical itself. Clear? So pay attention everyone, pay attention to each and every point. It is going to be a full-fledged revision of your working stress method. Okay, so if you miss in between, if you leave in between, you are going to miss various points in this session. Okay, so before starting with the session, let me introduce myself everyone. My name is Rohan and I scored an All India rank of 96 in GATE 2020. And prior to that, I have also scored an All India rank of 366 in GATE 2016. I have a master's degree in structural engineering from IC Bangalore. And these are the subjects that I teach at Gradeup, guys. Okay. Now, this is the numerical which we are going to discuss in the today's session. Okay. So read the numerical first. Calculate movement of resistance of an RCC beam of size of 400 mm into 760 mm, provided with 60 mm effective cover, with area of steel also given as in A part, it is 4 bars of 16 mm dia in the tension side, and B part 6 bars of 25 mm dia. M30 concrete is used and Fe415 steel is used. Use working stress method and also calculate movement of resistance of the balance section and area of steel required for the same. So you have to find out the movement of resistance for the given area of steel and for the balance section. Now the steps that are going to be involved in this question are, in the step one, we are going to find out critical depth of the neutral axis. Then step 2, you are going to find actual depth of neutral axis, XA. And then in step 3, you are going to compare XA with XE. And based upon that, you are going to tell type of section. whether it is an under reinforced section, balanced section, or an over reinforced section type of section. And based upon that type of section, in step 4, we are going to find out the movement of resistance of the section. So these are in short the steps involved in the calculation of this question. Is this much clear to everyone? Is this much clear to all? Are the steps up to this point clear to all? Yes or no? Shall we start with the numerical now? Shall we start with the numerical now, everyone? Okay. Now let us start with the numerical class. So in the first part, so in the A part, we are given how many bars? 4 bars of 16 mm dia. 4 bars of 16 mm dia. 4 bars of 16 mm dia. Right? So let us draw the section first. So this is my section. We are given overall depth is 760, and you are provided with 4 bars of 16 mm dia at an effective cover of 60 mm, right? So the effective depth is going to be this one, which is equal to 700 minus 60. Okay. Now step 1 is find. Step 1. In step 1, we are going to find out critical depth of neutral axis. Critical depth of neutral axis is equal to 93.33 upon T plus 93.33 into D in working stress method, which is equal to, can be also written as MC upon T plus MC into D, where M is equal to modular ratio, that is equal to 280 upon 3 sigma CBC, and C over here refers to the sigma CBC. So MC means M into sigma CBC. So M into C, which is equal to M into sigma CBC, which is equal to 280 upon 3, which is nothing but 93.33. That is what I have written over here. And for FE415, your T is equal to nothing but it is equal to sigma ST. And for FE415, sigma ST is equal to 230 Newton per mm square in working stress method. Right? Right, everyone? Is it clear to all? Okay, now let us substitute these values. So 93.33 upon 230 plus 93.33 into effective depth, that is 700. So which will come out to be equal to which will come out to be equal to 2.2.05 mm. Then step 2, you have to find out the actual depth of the neutral axis. So for actual depth of neutral axis, you have to equate movement of area on tension and compression side. So let us say this is your actual depth of the neutral axis. So in working stress method, we design it as a cracked section. This is the actual depth of neutral axis. So we neglect the area of concrete on the tension side. So the remaining area is like this one. This is the area of concrete on the compression side, and we neglect the area of concrete on the tension side. And we draw an equivalent area of concrete for steel like this. So we have an equivalent area of concrete in the place of steel, whose area is, this area is M times AST, right? And this distance is how much? This distance is D minus XA. Clear? So movement of area, the above area will have a movement about XA by 2. This is XA by 2. So movement of area will be how much? Movement of area will be B into XA, area of the compression concrete, into XA by 2, which is equal to M times AST into D minus XA. Into D minus XA, substituting all the values. B is 400 into XA square by 2 is equal to M is 9.33 into AST, that is 4 bars of 16 mm dia, into 700 minus XA. So if you solve this one, you will get XA is equal to how much? Solve it and tell me, everyone. What is the XA value you are getting from here? What is the value of XA that you are getting from this one? Calculate and tell me, everyone. You will get your XA as 144.375 mm. And since your XA, you can see it is less than your XC. It is less than your critical depth of neutral axis, which is equal to 202.05 mm. So step 3 we are going to compare. Since XA is less than XC, it is an under reinforced section. It is an under reinforced section. And an under reinforced section, your CA is less than sigma CBC and TA is equal to sigma ST. So your moment of resistance is, your moment of resistance will come out to be equal to, T force into lever arm, which is equal to sigma ST into AST into D minus XC by XA by 3, which is equal to sigma ST is 230, AST is 4 into pi by 4 into 16 square into D is 700 minus 144.375 divided by 3. So this will be in Newton mm, 10 to the power minus 6 kilonewton meter. So it will come out to be equal to 120.58 kilonewton meter. So the moment of resistance for this amount of steel is coming out to be 120.58 kilonewton meter. Clear? Now what is the moment of resistance of a balance section? So calculate the moment of resistance for balance section. For balance section is equal to balance will be equal to either C force into lever arm, or it can be written as either T force into lever arm. But we do not know the AST balance, so C force into lever arm, that is equal to sigma CBC by 2 into B into XC into D minus XC by 3, which is equal to sigma CB is 10 divided by 2 into B is 400 into XC is 202.05 into depth is 700, effective depth into 202.05 divided by 3 into 10 to the power of minus 6 to get it in kilonewton meter. So this you will get equal to this value. Calculate and tell me what is the value you are getting, moment of resistance for the balance section. You will get this one equal to 255.94 kilonewton, and therefore our under reinforced section having moment of resistance less than that of the balance section, which is evident. which is evident. So the area of steel corresponding to the balance section, what is it? So moment of resistance of the balance section is also equal to T force into lever arm, right? Which is equal to AST balanced into sigma ST into D minus XC by 3. So from here, calculate AST balance. So 255.94 into 10 to the power of 6, which is equal to AST balanced into 230 into D is 700 minus 202.05 divided by 3. So from here, your AST balance will come out to be equal to, your AST balanced will come out to be equal to 1758.92 mm square. So if we use 16 mm dia bars, what are the number of bars required? Will be equal to 1758 divided by pi by 4 into 16 square, which is equal to 8.75, that is almost 9 bars are required. 9 bars are required. So we have provided 4 bars over here, and for balance section we require 9 bars. So from here also it is evident that it is an under reinforced section. Okay. So these are the concepts which were required to understand the working stress method. Okay. Is there any doubt up till now, everyone? The second part, you have to calculate the moment of resistance based upon the 6 bars of 25 mm dia. Okay, this also you can calculate, and you will get an over reinforced section over here. You will get an over reinforced section. This is your homework. You can do this as a homework. Okay, so that's all for the today's session, guys. So these are the courses. Let me introduce you the courses which are offered at Gradeup. So we have a Gear Up course. So Gear Up course is basically a concept building course which offers you basic concepts. And Rank Up course is the course in which it is good for the students who want to improve their gate rank. So it is basically a score improvement course. And Vision 2022 course is for the students who are aiming for gate and DSC 2022. And if you subscribe to Gradeup Super, you get subscription to all the 3 courses. You get subscription to all the courses. Vinay limit state method we have discussed in the previous class. You can check the previous class. Over there we have discussed the limit state method. Okay. So these are the faculties who are going to be guiding you through your preparation. Okay. And we have, these are our past achievers. We have 60 plus students in top 100 from Gradeup, guys. And you have to, with Gradeup Super, you have the subscription of 6 months, 12 months and 24 months. And for any doubt regarding membership, you can contact on this given contact number, or you can also drop an email on this given email address. So with Gradeup Super, you get unlimited access to all the structured live courses and mock tests which are offered at Gradeup, guys. So that's all for the today's session, guys. Thank you. Goodbye. See you in the next session, guys. Bye, guys.